last time we started discussing the idea of inheritance, which is an important part of the entire object oriented modeling idea. Inheritance is something where new classes are created from current classes, and the new classes inherit the attributes and operations and or operations of existing classes. In other words, it is kind of a you might say specialization. Inheritance allows both generalization and specialization, in the sense that you can I will show examples of what I mean by generalization and what I mean by specialization. Specialization, see, given a college in which there are both science students and art students, then the science students and art students are two subclasses of the class students, and the subclass, the two subclasses inherit properties of the parents of class being student, and in addition to that they may have their own special attributes and operations. In other words, a science student as well as an art student is a student, but the operations and maybe even attributes which are important as far as the art student is concerned may be different from that of a science student, but there will be some common attributes. So the specialization really is based on the fact that the subclasses inherit the properties from main class, some of the properties, and have their own special properties. Like for instance, the class is a college student, and the attributes of a class are roll number, name, address, year of study. That is common to all students, and operations which are common for all students is admit a student or promote a student. And then you can have subclasses which inherit some of the attributes, like science student, roll number, name, address, year of study will again be repeated because that is common for all students. Besides that, I am putting a department name or department code and laboratory name, because he may belong to a particular department and to a particular laboratory in that department, because departments are sometimes classified into labs of different types. And apart from admit and promote, it may have a new operation of calculating fee, because the fee structure for science students may be different from the fee structure for the art student. So when you want to calculate the fees, the operations as we pointed out in the last lecture are effectively methods or programs which are encapsulated into the object. So the collection of fees may be based on certain rules. I give a very simple example of calculating laboratory fees. Normally the science student has lab fee and the art student does not have lab fee. So there is a calculation of lab fee, but in general the two different student classes, namely the art student and science student, may have different fee structures, and implementing a fee structure may really depend on the rules which are relevant to them. So calculate fee, in fact I put laboratory fees and calculate field trip fee, but if you just put calculate fee, then also it is all right, because we will come back to this question. I mean, it's the same operation, which is name is same, but depending on the class, the actual program which is implemented would be different. So if I just give an order, calculate fee to this, then it will based on the specialized rules for the inherited class, it will actually calculate fee for that, calculate or do the work which is assigned for that. Similarly, generalization is given a class eye surgeon we can generalize it to surgeons, because eye surgeon is only a part of a surgeon, and which will inherit most of the attributes operating in the eye surgeon. You can look at it in kind of backwards. From a class general class like a surgeon, I can go to an eye surgeon which inherits the properties of the general surgeon, and also has got some special properties or special attributes and special operations. And if it is an orthopedic surgeon, that person also is a surgeon. He will also use an operation theatre, he will also do operations and so on, but the fee he charges may be different, and many other operation may be different, and the attributes also may be different. Okay. So instead of having separate kind of all types of surgeons, you can look at the surgeon class, and so the generalization is that you go from small to big, and from big you get to several small subclasses. So you kind of get to the class surgeon and then make it a specialized set depending upon different types of surgeons. Similarly, a general class school will inherit many of the properties of middle school, primary school and all that, and vice versa. A school is more general than the middle school, primary school and so on. In other words, the reason why we talk like this, one might say, why not we always start with a school and go to middle school, primary school and so on, because we know that the specialized case of classes, of schools. But let us look at an example. Maybe if there is a school which is currently a primary school, and they want to upgrade to become a secondary school and later on a high school, at the beginning they had a class which is relevant only to primary school students, and it has certain attributes and operations. When the school expands to have a secondary classes also, then you would the secondary school students will inherit some of the properties of the primary school students. Now you can in fact say that you have general class students, and now you realize that the school may become high school tomorrow and also become a PUC type institution with two years of almost college study after the school. So in order to accommodate changes which may come in the future, it's always a good idea to look at a generalized situation and make primary student, even though school may be only primary school, make it a subclass of this class of student, and then later on you add new things. You can painlessly add new subclasses of that superclass, namely the student class. That is the whole idea of inheritance, which in other words, you can always generalize and from there inherit properties and specialize. And so you can look a little bit ahead of what may happen in the future and look at some generalized classes which may not currently have too many subclasses, but as time progresses more subclasses may occur, we inherit many of the properties of general class. This is a general idea, or the fact that the object orientation primarily promotes what I would call change. It accommodates change, and so while you actually do a design, you have to keep in mind that the whole idea in software is primarily to accommodate change, and while you do that, it's always good to generalize and then from there specialize. That is the whole idea. If inheritance allows this kind of generalization and specialization. So given a class doctor, we can obtain subclasses. In other words, you can go beyond surgeon, because a particular hospital normally would have not only surgeons but physicians. It will have specialist physicians in different areas and so on, and it may have a general physician, or in general, doctors, if you look at a class doctor, there are specialized doctors who are consulting doctors and general practitioners who effectively are you might say your family doctor who is not specialized in anything. If you have a small illness, you go to a local, you will have family doctor, and if it is a very complex illness, he will suggest that you go to a specialist doctor. If it is a surgical case, he will refer you to a surgeon, and so on. In other words, you can always again look at doctor as a class, and doctors have certain common attributes regardless of whether they are surgeons, general physicians, specialists, and so on. So all these will inherit properties of doctor and will have their own new attributes and operations. So this is essentially what the same idea like in school. Now polymorphism is somewhat slightly different idea. By polymorphism, we mean the ability to manipulate objects of different distinct classes knowing only their common properties. In other words, there are some common properties which are there for both, and but then the operations or methods which are encapsulated within the object are really based on the attributes of that particular object class. Okay. So if you look at object classes of hospital and school, both have some common operations, like both the word admit will have meaning for both the school and the hospital. In a school context, it will be admit a student, and there will be certain kind of rules you follow for admission. When you say admit in the hospital context, then it essentially would mean admit a patient to the hospital as an inpatient. Both are meaningful, but they are interpreted entirely differently depending on the class in which they are put. The advantage of using this, that is, in other words, the word, the operation of attribute, the operation admit takes on two different avatars. In one avatar, it is actually related to the students, and the other avatar which goes into the admitting in the hospitals. Okay, so that is the reason why it is called polymorphism. There is a same thing has two different meanings depending on the context. Okay, and one might ask why should we have the same word used at two places? The reason is, from a point of view of a user or a person who is going to use a system, in the case of a context of a school, the admit will have a meaning, and in the context of a hospital, the same word admit will have a different meaning. In fact, when we talked about the collection of fees for the subclasses, art student and science student, I said the rules for fees will be quite different for the art student and for the science student. So you can just, if you say collect fee for both these, in fact you are using polymorphism in a way, in the sense that when you say collect fee, the rules which are implemented or the program or the methods which are encapsulated within the object for a subclass art student will be different from subclass science student. So this is the whole idea of polymorphism. The same operation has two different meanings based on the context. Advantage of polymorphism is, as I said, ease of understanding. When you say collect fee, you know, collect fee is clear for the art student or science student. In fact, collect fee may even be the same is relevant for a hospital or a school. In one case it may be a fee, doctor's fee, the other case may be a school fee. Okay, but collect fee has got different contextual meaning depending upon where you use it. Okay, So a client gives generic request. So you can look at, if I look at objects as contractors. So the contractors will interpret this generic request and execute it appropriate to circumstances. Okay. So if there is a contractor who is doing the contract, then the contractor will interpret depending upon the contract you are given. Find out the bill. So you may have two different contractors. One contractor giving furniture, the other contractor may be catering. But most cases you can say if you give an order, create a bill or build a customer, then each one will create this bill or build a customer based on their own individual rules and individual attributes and so on. Okay. So from the point of view of the application, it's a meaningful kind of word, and meaning is entirely contextual based on the context. Now the greatest difficulty, the most interesting problem, the most difficult problem in object oriented system design is to identify objects. What are objects in an application? Okay, and that is even there is no again algorithmic method of identifying objects. What I mean by algorithmic method is you cannot essentially expect a computer program to be able to identify objects. The identification of objects, because it is all semantic, it has got some meaning, and because of that, and also contextual meaning. So because of all these things, it is a responsibility of a system analyst to be able to identify objects. And object identification is really a very, very challenging part of object oriented modeling. And once you model, then this model can be used for system design, and then at lower level object-oriented programming. Okay. But modeling is the start of the entire cycle of object-oriented design in general. Okay. So normally you always start with a system requirement specification. SRS is the real start of your entire operation. Okay. So the simple method is to identify nouns, the requirement specifications, their potential objects. See, they are not, doesn't mean that every noun which occurs in a system requirement specification is an object, because you will normally find SRS will be a very long statement. Some cases SRS may run into few pages, and you don't want to proliferate objects unnecessarily. Also identifying, if you kind of look at all nouns blindly, many of them will be irrelevant. So you have to, the most important part of it is having identified potential objects which are all normally noun classes, then how do you weed out and take out only those which are relevant for a given situation. So that is the part which is challenging. Later on we will see in this lecture that people have suggested many methods of doing this. In fact, one of the methods we will discuss requires that object identification is not done by a single individual who looks at the SRS, but by a team which consists of both the user and you are users, analyst or analysts who may be involved in this project, and the project head who essentially looks at the entire project from a bird's eye view. So a team normally is formed, and the team is the one which normally identifies. But I am going to give an idea of how the identification process is done, and later on we will look at the so-called modeling methods or the actual industry practices, you might say, of doing this, because as far as you are concerned, when you are in a college and learning this, you don't really come across very large systems. In fact, the entire object oriented modeling is relevant only for very large systems. For very small toy systems which you encounter, as examples, which in fact I should blame myself also, the examples I have given are really toy examples, because I have to be able to accommodate in a certain short span of time, and I got to kind of explain it, the basic ideas. So I can't really take a real problem which has got something like 10 pages of SRS and may lead to 100,000 lines of code and so on. So by force we have to kind of look at only smaller problems. But you have to keep in mind, at the back of your mind always, that the object oriented modeling and the entire object oriented design is much more relevant for very large problems where a large number of objects will be there, and the idea of inheritance, polymorphism and so on become extremely important in what I would say programming in the large rather than programming in the small, or equivalently might say information system design in the large versus information system design in the small. We are essentially these methods are relevant. The object orientation idea is relevant to the systems when you do information systems in the large. Okay, but of course we have to understand what these mean. Okay, then we identify verbs in the requirements specification. These are potential operations. Not every verb is an operation. It's a potential operation, and so you have to kind of again weed out some which are not absolutely essential. We remind again that an object class has many objects as members. There is a distinction between an object, a class and an object, individual object. But of course we have been using it synonymously. Literature also does it synonymously. Okay, wherever there is no possibility of confusion, we use them synonymously. That's what we have been doing. Objects should perform assigned services. In other words, they must have responsibilities specified to them, and specified by us, by the system designer or system analyst to them. And objects must have relevant attributes which are necessary to perform the service. Of course, attributes must have non-null values. In other words, attributes must have values, otherwise why should it be there? Okay. So every attribute you put into the object must have some value and a role to play. If there is no role to play, it has no business being part of the attribute set. A class must be essential for functioning as a system. In other words, the information in the class must be preserved in the sense that it is, if it is not preserved, the system will not function properly. That's what we really mean by the class being essential, because we cannot lose its states or lose its attribute. If we lose its attribute or state, then system will not work. Must have a common set of attributes and operations which are necessary for all occurrences of the object in the class. Because the point is obvious, because all objects together form an object class. So then every object must have attributes that are common to object class. Object should be independent of the implementation system. Okay, this is a cardinal rule. Implementation, particularly at the modeling time, implementation ideas are not at all relevant. Implementation ideas become relevant only when you start programming. So in this modeling, there is no question of there is no, you don't worry about implementation. So you select potential objects from the word statement, primarily by examining noun phrases, and I said that all nouns need not be. If there are some objects whose attributes do not change during the functional system, reject them. They are probably external entities. In other words, the attributes will change during the course of the operation of the system. So again, as I said, we will illustrate selecting objects from an example. I will take two examples. One example I am going to take is a process of admission in a university, and there are a set of system requirements specification, or you might say set of rules. The applicants send applications to a university registrar's office. So I am really giving a sequence of events. So the sequence of events starts with an applicant, there are several applicants who want to get admitted to a college by sending applications to the registrar's office. A clerk in the registrar's office scrutinizes applications to see if the marks list is enclosed and fee is paid. As far as the registrar's office is concerned, they don't have any role to play in this example in terms of the final decision to be taken. They just do the clerical job of checking if the student application is complete. It's got the marks list, and it's got the fee, required fee is paid, and so on. And whatever requirements are there along with the application, when it is sent to the registrar's office, whether they are fulfilled or not, is what the registrar's office does. If a scrutiny is successful, the application itself are passed to a relevant department. In other words, they will sort the applications. The applications may be for different departments in the university, and each department may have certain number of seats, and they all have their own rules regarding admission. The sense that the marks requirement may be different, and the minimum qualification may be different, and so on. So department is the agency which does this kind of a final selection. Department has got a committee which scrutinizes the application. Applications are ranked. In other words, after scrutiny, finding out the marks of the student and other criteria, whatever the criteria may be, they rank order the students in terms of an admission list. Depending on the seats available, you rank order and say, suppose you got 40 seats. You decide to send 40 admit letters, and you may decide to have something like 5 on the waiting list. That depends upon your earlier experience in terms of how many people drop out after getting admission. Okay, that is a judgment of the department. So they may have some in the waiting list, and or beyond that, if they feel the student is not up to mark for admission, reject. And having done this scrutiny and having taken a decision, they send back a message, you might say, to the registrar's office. The appropriate clerk who sent that maybe, or you can send to the office, and the office will do whatever they want to do with it, and they will send back the message that so and so is admitted, so and so is waitlisted, so and so is rejected. And the registrar's office clerk, when he receives this intimation from the department, his responsibility is to send a letter to the candidate informing whether he is admitted, put on the waiting list, or rejected. So the result has to be given to the student. The potential objects, kind of looking at all the nouns, are applicant. Applicant, you can say applicant is a noun, and applicant looks like has a beginning of the entire cycle of applicant gives an application, and registrar's office has got a clerk who does this job, and this departmental committee is there. Now the question is how to select the relevant objects from this. Is it the clerk or is it the applicant or is it the application? You have to decide. So the decision is based on certain questions you ask. In other words, you try to do a filtering based on certain criteria, and the criteria is certain questions you ask yourself as a modeler. Does this satisfy these criteria? If it satisfies these criteria, then I'll take it as a potential object. A potential object, I would kind of take it as a real object. Otherwise, I'll reject it. Or does the attributes or operations performed an attribute? Now, these are two important questions, right? And if you look at applicant as it's a potential object, applicant has attributes. The applicant name, roll number. No, roll number is not won't be there because it's an applicant. There will be a serial number or something which is assigned. Okay, but that assigning will be done by the registrar's office, not by the applicant. But the applicant's name, address, degree passed, and all that will be there. But the operations are not performed on the applicant per se. We are performing operations on the application. See, applicant is as far as the procedure for admission is concerned, the identity of the applicant is irrelevant. Whether it is Krishnan or Raman or Srinivasan doesn't really matter as far as the procedure is concerned. The process depends only on certain attributes like marks. The address of the applicant is not relevant, his name is not relevant, and the only thing which are relevant is in terms of whether he has obtained a degree, what marks did he get, what subject did he pass in, has his fee paid, and is the marks list enclosed, things like that. So the applicant has no relevance, but the application is the one which is actually used by the clerks. So application of attributes and operations are performed in application. Whatever attributes are there, like for instance the marks list, the fee paid, and all that attributes are used by both the registrar's office clerk as well as the departmental committee to come up with the decision of whether admit or waitlist or reject. Okay. So it's got application has got attributes and operations are performed on using these attributes. Result is conveyed to the applicant, but the result is based on the application, and the address is required only for communicating the result. So there is no operation, only he gets a signal, you might say, a message. So this applicant it might call is an external entity. Say external entity who sends some data and gets back some result. In this case, data is application, result is admit or not admit or waitlist or whatever. Okay. So, admit application is an object. You might say application looks inanimate. See, it's any, but it's a kind of a tangible entity, and you are doing operations based on that what is contained in the application. So it's essentially a document which has got a meaningful existence as far as the system is concerned. So in the model, application becomes a class. So a specific application is a member of the class applications. So the class, general class application may have individual objects which are all several applications, as a set of applications. Okay. Registrar office clerk, the clerk itself has got attributes like his age, his salary, his address, and so on. But that they are irrelevant. What the task performed by that applicant of the clerk on the application are the only things which are relevant. So reject the clerk as an object, but registrar's office has some function to do, and the function is performed by the clerk, you might say. So to that extent, the operations performed are relevant, but they are all performed in the application, and so application is a relevant one, and then department, there will be some operation will be performed by the registrar's office, which we will come to. Department is taken as a potential object, it is attributes, operations are performed using attributes, and the attributes are used by the department, and so in other words the operations which are performed use attributes, namely the marks list, what marks he obtained, which university he passed from, and so on. That is all used, and the operation also performed. So department is a potential object. So application I am admitting as a class, and departments admitting as another class, and operations on the application are scrutinize, send application to department, and send response to the student, admit, wait reject the applicant. Okay. So response is admit, wait list, reject to the applicant, see, and the scrutinization is done by the clerk, and send application department, the clerk does it. So attributes of application number, applicant name, because you normally assign a number, as I said, the applicant name, applicant address, mark sheet, fee paid receipt, department applied code, application status, is admitted or not admitted, because it will become a permanent record later on. If there is later on a question asked about a particular applicant, because maybe the applicant did not receive any letter, so if he inquires about the status of the application, immediately the office must be able to respond and give a status, whether it is still being scrutinized, or it is in the department, or has a letter already been sent. So there are three possible states: being scrutinized in the office, registrar's office, sent to department, that means department is scrutinizing, and third is the decision taken and letter dispatched. So that is important. Now I added clerk code there, the application, mainly because there is some, normally you would like to track down which clerk scrutinized which application. The reason being, if suppose there is some later on a problem, and you would like to find out who did this job. Suppose a fellow has goofed up, and you should be able to pinpoint responsibility. That is the reason why we put the clerk code there. And of course, if the requirement also says that the department looks at the clerk code and sends it back to that particular clerk, but normally it is not done, because the department will just send it to the registrar's office, and the registrar's office may use the clerk code to assign this task of sending admit reject letter back to the student, to the same clerk who scrutinized. So to that extent, clerk code is important from the for you might say so-called audit trail. It keeps a trail of what happened. And if you look at the department, department's attributes are department's code, department's name, courses offered by the department, number of students to be admitted to that particular course, number to be waitlisted, minimum entry qualifications for that course, status of application. That is, in other words, again, status of application is in this case it is being examined, or it is being a decision has been taken, or it is kept in abeyance maybe. You see, if they have some problem with in terms of the authenticity of the marks and so on, they may put in abeyance or something like that, whatever. So it depends on the particular detail, depends upon a particular situation. The operations, of course, scrutinize application, send application status. That is, after scrutiny, send application status to the registrar's office, which will use the status information to act further. Now, this is a simple example where there are only two objects, and two objects communicate with one another, and external entity being applicant. But this, if you have this brings out another important point. The point is that the admission process may be different in different colleges or universities, in the sense that the scrutiny and so on may be different, but normally the attributes will be same, operation will be similar. So in other words, today you may be doing something for the university X, tomorrow you will be asked to model for similar problem for a university Y. In this case, you don't have to go back to the drawing board and start from scratch for the university Y, because you already done university X, and you can reuse same objects. The reusing being that the idea of application department will be common. Only the details of how application is scrutinized and how the reaction or acceptance takes place would vary from university to university to university, or college to college to college. So the name of the operation may still be same, scrutinize and so on, but the methods implement may vary depending upon the specific university. So in other words, these operations are polymorphic. Okay, you have different situations, you may implement different methods, but attributes are somewhat common. Okay, so that's the whole idea of saying that reuse is promoted by object orientation. So reuse is possible. I am taking one more, little bit more complex example, which we started looking at the very beginning. This is an example of a company which receives a lot of goods from vendors, and they are all received by receiving office. So, lots of items come into the receiving office from vendors, and receiving office checks delivery note which comes along with the item against the orders. In fact, we came up with a data flow diagram for this earlier, and against orders placed, and detects excess or deficient deliveries if any. So, if there is a excess delivery or deficient delivery, then normally the purchase office will be informed about this. So, a discrepancy note is sent to the purchase office if any, and the receiving office, after receiving the items, sends an items received note which may be a copy of the delivery note, or it may be somewhat different from internal structure of the internal data structure may be there, to the inspection office. So, inspection office is the next entity. The inspection office physically inspects items received and accepts good items. So, which again we said earlier, and bad items are returned to the vendor. So, items accepted note is sent to the stores office. Okay, stores office gets the items accepted, discrepancy note sent to the purchase office. Stores office will update inventory based on items accepted note. Whenever inspection inspects and accepts, then the stores will update the inventory. And once they update the inventory, they send a taken into stock report to the accounts office for payment to the vendor. So, that means these number of items came, found good by inspection, and we have got a document saying that these have been accepted and have been taken into stock. So, the stock or inventory is being updated by the stores, and because payment has been made after the inventory is updated, the information is sent to the accounts office, and the accounts office based on this note will send a payment to the vendor. Now, what I have done is underline all the candidate objects. Candidate, there is potential objects, I call it candidate objects. So, receiving office is a potential object, items, vendors, delivery note, orders, discrepancy note, purchase office, again receive, because receiving office again items received note, and inspection office. These are potential objects. Again inspection office, again items will be there, vendor, items accepted, items again, and stores office, discrepancy note, and purchase office. Again stores office, items accepted note, stores office, accounts office, payment, and vendor. Accounts office, payment, and vendors again come here. Now, we took all those underlined potential objects and list them. Receiving office, items, vendors, delivery note, orders, discrepancy note, purchase office, items received note, inspection office, accepted items note, stores office, inventory, goods taken in stock report, accounts office, payment voucher. 15 potential objects are there. Some of these are physical entities like items, vendors, and so on. Some are documents like orders, delivery note, discrepancy note, and so on. And some are entities which do some job like receiving office, purchase office, stores office, accounts office, and so on. Each one has got a function to play based on the documents which flow. So now we have the job of filtering out from this set of 15 potential objects. Let's see if there is any more. Yeah, 15 potential objects here, and take out those which seem to be relevant. Now, how do we start picking out what is relevant and what is irrelevant? This is the most difficult part of any object-oriented modeling. To kind of do an informed selection or a common sense selection, you might say. Because of informed and common sense selection, that is why I said very often experts suggest that should not really be done by a single analyst. Normally it should be a team which kind of decides. That's what many experts in this area say. I also agree with them that it is not, it can become arbitrary if a particular person does it. There is a small group which does it, maybe they will debate, and based on the debate certain good ideas will come on what can be included, what need not be included. So from that point of view, a team is always very useful. So items, orders, inventory, payment voucher, all these are better attributes, but there is no actual operations performed on the items. Similarly, the orders are a dumb document, okay, which comes. No operations performed on the order in that sense, because order has been placed already. Inventory is some kind of a database which is sitting there. And payment voucher is again another document which is not really, any operations are not performed. That is actually a result of a certain operation performed in the accounts office. So I will effectively look at the functional parts, functional entities you might say, in this set of potential objects, which are operations to perform on the attributes of whatever documents they need to be able to perform the operation. As we have been always saying, object is something which got attributes encapsulated with operations. In other words, there is some data structure which is encapsulated along with the operations of the data structure. The operations are triggered by some messages or request coming from an external source or another cooperating object which may send this request for cooperation. So in general, we look at an object-oriented system as a set of objects which all have some independent existence, but they collaborate or cooperate to get a particular job done. So from that point of view, receiving office, even though the office's attributes are not relevant, its functional attributes are important. And it derives the attributes from the another delivery note comes to the receiving office, it compares the delivery note against the order which is in place of the vendor. Based on the comparison, some action is taken. Action being sending it a discrepancy note, and also sending the items of received note to the next step, namely inspection. So from that point of view, you might say that it's a potential object whose attributes I will come, it has to inherit the attributes of delivery note and order to vendor. There is these two it has to inherit as attributes, and operations are of course specific for the what the receiving office is supposed to do. Okay, so those operations will be relevant. So look at vendors. Vendors looks as though it is a potential object because they are an attribute like vendor code, vendor name, vendor address, and so on. But there is no particular operation performed on the vendor in this case. So suppose you have a different situation where you want to kind of have kind of a new vendor added, or the vendor has some operations can be performed on the vendor, namely like address change or things like that. They of course will become a potential object. In this case, I am assuming that vendor is no operating object are needed in this application. Attributes are necessary for the accounts office to make payment because address is required. So vendor is an external object with whom we interact. The sense that the vendor is the person who sends the item, he delivers the item with a delivery note, and the vendor is the ultimate person to whom the payment goes. So vendor essentially is an external entity, and attributes of the vendor is important from the point of view of the operations performed by some other object. But vendor itself as an object is not really relevant in this example. There may be other examples where vendors may become relevant if the vendor plays a very central role in the entire, in this case to some extent you can say he got a role to play, but there are certain operations which suppose had to be performed on the vendor, like you might say reject a vendor and so on, then it may become necessary. So I think I will continue from this point onwards and look at other potential objects, because it's a very long example and I can't, I am running out of time. So I think I will continue from here and revisit this example next time.